This lesson is for FST Lesson 8.4 on Arithmetic Series. It's important that students understand the difference between a series and a sequence. For the most part, a sequence is a list of numbers separated by commas, where a series is when you take the terms in a sequence and add them together. So that's why a series is referred to as the sum of the terms in an arithmetic sequence. So today our focus is on arithmetic series. Know that there are geometric series as well, and we're going to learn those in a different lesson. So you can see here that if I take the first term plus the second term plus the third term and so on all the way to the last term, if I wrote it like that, that would take up a lot of space. So another way that we write a series is by using the sigma notation that we learned way back in the beginning of the school year. So in this case, this is a much more condensed version of what I just wrote over here. So I'd take the a values and add them up from 1 to n, which is exactly what this says, just in a different way. So students need to not be upset about the fact that sigma is back, because sigma is just a condensed way of writing that you're going to be doing a sum, which we're now going to call a series. To put it in more practical or real life terms, I want to look at the example that's listed here from page 522 in your book. Suppose that a virus enters a community and the number of new infections each week forms an arithmetic sequence. So notice how the numbers are listed with a comma separating each term. If there were 6 cases the first week and in each week thereafter 4 more new cases than the week before, the sequence would be 6, 10, 14, 18, 22, and so on. And that would be the number of new cases in the nth week as described by the formulas below. So these formulas here are exactly what we learned back in 8.1 and 8.2. The recursive formula for an arithmetic sequence is the first term plus the previous term plus whatever the difference is between the terms. So in this case, it's a 4. If we do it explicitly, we would take 6 plus n minus 1 times 4. I put a box around this formula because the second formula is the same, but one that we should avoid. The 4 is in a different location on this formula versus this one. I like this one better, the one that's listed on the left, because the 4 clearly needs to be distributed. On the second one, it's very common for students to add the 6 and the 4 together when they should not. The order of operations here dictates that you need to do 4 times whatever's inside the parentheses before you add. So I'd recommend students disregard this one, but know that if it does show up, it's the same as if the 4 were on the other side. So let's talk about the sequence versus the series. The sequence that they gave us, the 6, 10, 14, 18, 22, those are the number of new cases each week. So those would be separated by commas. But what those numbers don't tell us is how many people are infected altogether. So if we take week 1 and add the number of new cases to it, there would be 16 people who are indeed sick between the 2 weeks. Then if we keep going, add 16 plus the new cases in week 3, now we'd have 30 people total who are sick. And that idea continues here. So when you add up the totals as you go, that is referred to as a series. Another example I want to illustrate here is a real-life example. This one is a true story. As punishment for misbehavior, a 3rd grader, a long time ago, back when students used slates in class, little mini chalkboard that they would use to write their answers and take their notes, a famous mathematician whose last name is Gauss was asked to add the integers from 1 to 100. I think the teacher was annoyed by this particular student because he was super smart. And I'm guessing that he was probably annoying because he was super smart. He was probably super bored in her class, and so that's why he was misbehaving. So this kid, as a 3rd grader, grew up to be a very famous mathematician, but this problem ended up becoming very famous. The teacher asked him to add the numbers from 1 to 100, which would normally be, a student sitting there with their slate, adding up the numbers as they go, and taking a long time to do it. But if you think about the way that Mr. Gauss thought about it, the numbers have a little bit of a pattern to them. So I'm going to just write out a few of the terms here so you can see them. And so what Gauss figured out is that the pattern that exists here is one that you can figure out pretty quickly. The 1 and the 100 would add together to make 101. But so would 2 plus 99. That would also make 101. So would 3 plus 98. That would also make 101. So if we have a bunch of 101s, how many would there be? So if we're taking a number from this end and a number from that end and adding them together, wouldn't there only be 50 terms altogether? So if I just took 50 times 101, I'd end up having my answer. So what's cool about that, and you can read more about it in your textbook if you'd like on 523 and 524, they've summarized that whole idea now into a formula, which works for any sequence or any series. If you take the first term and the last term and add them together and multiply by half the number of terms, you'll get the sum. So rather than sitting there and adding them by hand, you can just do this formula. The only drawback to that formula is if you don't know the last term, then it's not going to work. So we have an alternate formula as well. The second formula would be used if you don't know the last term. If students are uncomfortable memorizing two more formulas, simply memorize the second one. The second one has a resemblance to a formula we've already learned. So if you look just for a moment at this part, a sub 1 plus n minus 1 times d should look familiar. That is the formula for an arithmetic sequence. It's the explicit formula. So all students really need to remember is that the series formula is just a basic modification of that. So we took the explicit formula, took the first term times 2, and then just multiplied the whole thing by number of terms divided by 2. So it should be pretty easy to remember those two formulas. Let's try them with a couple more practice problems. If a student borrows $8,000 for college expenses and the loan was to be repaid over a 100-month period with monthly payments as follows, how much did the student pay over the life of the loan? Notice that this problem does not mention the word series. It also doesn't use the word total, but it is implied in the way that it is worded. When a student pays back the entire life of the loan, that means they will have paid back all of these values added together. So there's an implied series mentioned here. Students should not ask during a test or a quiz if a question is a sequence or a series, because that is going to be what I'm testing you to figure out. Notice that what's given here is a list of numbers separated by commas. This is a sequence, but we want to add them up, so we're going to be finding a series. Notice a very small detail. This sequence has a period at the end, which means this is the last term. That's a good thing to notice because now we can use Gauss's formula, the shorter version of the formulas that we're learning today. First term obviously is here, so we're going to simply say if there's 100 terms divided by 2, we're going to multiply that by 120 plus 70.5. Keep in mind, students, that you could do a little bit even further shortcut here. Most students, I think, would know that 100 divided by 2 is 50. So all you need to do on your calculator is add these two together and then multiply by 50. And when you do that, you should get 9525. So obviously when you pay back a loan, you're going to pay back more than what you bargained for, more than what you borrowed. So to find the total interest paid on the loan, you just take how much you got for your answer minus the original loan amount. Now that question B is not a Chapter 8 type question. Question B here is just a general knowledge question about what interest means when you take out a loan. So the difference between how much you pay back and how much you borrowed is $15.25. So you end up paying back an extra $15.25 when you loan this money, or when you borrow this money. I want to just point out before we move away from this question that on part A, you didn't have to use this formula. You could have also used the alternate formula. So I just want to quickly demonstrate that just for a little bit of practice for students. So again, there are 100 terms here. They tell us that in the question. So I still do 100 divided by 2. I'm going to take 2 times the first term, and then I'm going to do n minus 1. So in this case, I know that that's going to be a 99. 100 minus 1 is 99. And then I multiply by whatever the d is. Now the d is not given to us directly, but because the sequence is here, we can figure out what that d would be. Clearly the numbers are decreasing, so I want to make sure to include the fact that that D value is a negative. And I can see here that it's going down by 50 cents, so I'm just going to say that the D value here is negative 0.5. So now when you type that in, students, you want to make sure to try it with your graphing calculator or at least a scientific, because these can be a little bit trickier to type in because there's more stuff there to do. Keep in mind that there is multiplication in 2 locations. You'll want to do the multiplication before you add. And then at the very end you want to make sure not to forget to multiply by 50. Students should give that a try on their graphing calculator and make sure that they still get the same answer of 95.25. If they don't and they want assistance with their calculator, they should ask me for help during class. The last example that we're going to do is in training for a marathon. An athlete runs 7,500 meters on the first day, 8,000 meters on the next, 8,500 on the third, and so on. Each day he trains by running an additional 500 meters more than the previous day. What is the total distance the athlete will have run over 30 days? This one does have a huge hint here that we're looking for a total, so that's your hint that this is a series question. Notice that they begin by giving us a sequence. 7,500 on the first day, 8,000 on the second, 8,500. So the sequence is given, but we're not given how much he runs on day 30. Students could figure that out if they wished using the explicit formula for an arithmetic sequence, and then you could use the n over 2 plus a sub 1 times the last term. That would be an option, but I think it would be faster for us just to utilize equation number 2. Number of terms is 30 because it's a month-long project. Don't forget to divide by 2. Then we take 2 times the first term, which in this case is 7,500. Then I add to that n minus 1. Since the n here is 30, minus 1 is simply a 29. And then I multiply by d. D is given this time as 500. Always make note of whether or not that number is positive or negative. He's adding 500 each time, so we want to make sure that that number is indeed positive. Make sure you carefully type that in on your calculator. You'll want to multiply and then add, and then multiply by 15 after you're finished adding. When you're done there, you're going to get a very large number. It's going to be 442,500 meters. So again, on this one for students, it doesn't say or use the word series, but the inclusion of the word total for the full month is your hint that this is a series question.